All right, 8th graders. Well, we are continuing on here in Chapter 1, solving equations. And today we're going to be looking at a variety of some different equations that could come your way. So here we have a situation here where we have some problems with parentheses. And so this is what they call the distribution method, or whatever the case may be, having variables on both sides. And we have parentheses here, which we've talked about before, means multiplication. So we want to clear the parentheses first. So if we have negative 2x, negative 2 times x is going to be negative 2x. Negative 2 times negative 5 is going to be a positive 10, because a negative times a negative is a positive. Then that's going to equal 6 times 2, which is 12. All right, and then 6 times 0.5. 6 times 5, if you think about it, 6 times 5 would be 30. But since there's a number after, one digit after the decimal, we got to put one digit after the decimal here, which means we end up with 3.0 or just 3. So we're going to make that minus 3x because it's a negative number. So now I'm figuring out, okay, what do I want to do here? So I'm going to go ahead and I'm going to add 3x to both sides, okay? Going to add 3x to both sides. That's going to give me 0 there. If I come over here and I add 3x to both sides, because we want to isolate the variable, negative 2 plus 3 is 1. Now, I don't put 1x, so that's just going to leave me with x. Now, I got to put a 0 on both sides. So since I already have a 0 over here, I got to 0 this out. And that's 10 minus 10 is 0. So I got to subtract 10 from this side. 12 minus 10 is 2. And that leaves me with x equals 2. Well, that's not bad. It's pretty straightforward. Once again, we're going to clear the parentheses. And this second one, 6 times 4 minus y equals 2y. 6 times 4 is 24. 6 times a minus y is going to be a minus 6y. And so that's going to all equal 2y. Well, I want to isolate the variable. So I'm going to go ahead and add 6y to this side, make that 0, and just bring all the y over here. So I'm going to add 6y over here, and that's going to give me 8y. So that leaves me over here with 24 equals 8y. Well, now I just need to divide both sides by 8, because 8y divided by 8 will leave me just y. 24 divided by 8 equals 3, so 3 equals y. Last one here, before I go to the second board. Once again, we want to clear parentheses. 5 times w is 5w. 5 times a negative 2 is a negative 10, minus 10. Negative 2 times 1.5, well, if I plug that into my calculator, because we can always use our calculator, we've got 2 negative times 1.5. That equals negative 3. All right, so it's going to be negative 3w. Negative 2 times a positive 5 is a negative 10. So 5w minus 10 equals negative 3w minus 10. Well, that's kind of an interesting situation here. So I'm going to go ahead and I'm going to add 3w to both sides. That's going to give me 0 here. 5w plus 3w equals 8w. And then if I'm to say, okay, I need to have a 0 on both sides, so I'm going to add 10 here, and that's going to give me 0. I'm going to add 10 here. That's going to give me 0. And so I have 8w equals 0. And so, well, if 8w equals 0, 8 times something equals 0, okay? And that's going to tell me that w equals 0, which would work as a solution to this equation. All right, so let's go on to the next board, which is a little more straightforward. We're not as worried about the distributive method, so not clearing parentheses here on this second board. 15 minus 2x equals negative 7x. Now, once again, I want to isolate the variable, so I'm going to go ahead and I'm going to add 2x to both sides. That's going to give me 0 here. So if I come over here and I add 2x, well, negative 7 plus 2 is negative 5x. Okay? So that leaves me here with 15 equals negative 5x. And if 15 equals negative 5x, then I'm dividing both sides by negative 5 to isolate x. And 15 divided by negative 5 is going to be negative 3. X equals negative 3. Negative 3x equals 2x plus 20. So once again, I'm isolating the variable. So it looks like I just want to bring the 2x over here by subtracting 2x from both sides. And so I'm going to have negative 3 minus 2x. Well, negative 3 minus 2 is negative 5x. So that leaves me with negative 5x equals 20 is what's left on this side. And once again, I'm dividing both sides by negative 5. And negative 5x divided by negative 5 is just x. 20 divided by negative 5 is going to be negative 4. X equals negative 4. Last one for our video today, 2.5y plus 6 equals 4.5y minus 1. So once again, I'm going to go ahead, I'm just going to think here, 2.5y. And I want to point out that if I was to subtract 4.5y from both sides, as long as I kept a 0 on each side, you're going to get the same answer. So it's not, there's not one right way to decide how to deduct, because I could subtract 2.5y from both sides and then add 1, which is what I'm going to do. Or I could have subtracted 6 and subtracted 4.5y. Either way, y is going to be the same solution as long as I do it correctly. So this is going to leave me with 0. And I'm going to come back over here and subtract 2.5y. Well, 4.5 minus 2.5 is 2, so that's 2y. Then I'm going to put a 0 over here, so I'm going to add 1. That's going to give me 0. I'm going to add 1 to the 6, and that's going to give me 7. So that leaves me with 7 equals 2y. So I'm going to come over here, 7 equals 2y, which means I'm dividing everything by 2 to get y by itself. Well, 7 divided by 2 is going to be 7 over 2. 2y divided by 2 is going to be y. So I could leave my answer like this as y equals 7 over 2, because 7 over 2 is in simplest form, and that would be okay. However, I could also, depending on who your teacher is, I'm okay with this being left as a fraction in simplest form. Some teachers may want you to go ahead and turn that into a mixed number and actually do the division problem, 7 divided by 2. Well, 2 can go into 7 3 times. If I take 2 into 7 3 times, there will be 1 left over. My denominator here is 2. My denominator there is 2. I get 3.5. Those are just 2 different ways of writing the same number. All right, we'll talk to you later. 8th graders. Bye.